Welcome back. In previous lessons, we learned what is it that makes a number a perfect square. We know that 36 is a perfect square because when you square root it, you get a whole number. And it's a good idea to list all the perfect squares from 1 to 144 because you're going to use this list over and over and over again. I'm actually going to list it down here. 1, 4, 9, 16, 5 times 5 is 25, 6 times 6 is 36, 7 times 7, 8 times 8, 9 times 9, 10 times 10 is 100, 11 times 11 is 121, and 12 times 12 is 144. You might also want to get used to using 225, which is a perfect square, because that's a number that will be used a lot next year in geometry. Let's talk about the difference between exact values and estimates. Root 7 is an exact value. If I were to type this into my calculator, it would show me the number 2.6457513 . See, my calculator screen cuts off right there. And even if I were to round this like this is not exact. I had to truncate this decimal, which means to cut it off, to round to a certain number. This is an estimate. I'm not going to use that. This is an estimate. I'm not going to use that. This is the exact value. If I were to do the square root of 8, my calculator would say 2.828427125, and then again my calculator screen cuts off. Even if I were to include all of these numbers, that doesn't make it exact. I have to cut off this decimal and round it to whatever value belongs here. This is an estimate. This is an exact value. Or I could recognize that the square root of 8 is 4 times 2. I can square root this 4, that's 2, and then root 2 would still be there. These are both exact values, just one happens to be more simplified than the other. And there's no need for an estimate for the square root of 9 because it is a perfect square and its square root is a whole number. Both of these are the exact value, although again, this one is simplified. So in this case down here, it says for each number, write two numbers whose product is that number. One of the factors must be the highest perfect square that is a factor of that number. Well, I could say that 200 is 20 times 10. And that's true, it is 20 times 10. But 20 times 10, is 20 on this list? Is 10 on this list? No, neither one of these are perfect squares. So I'm going to choose 100 times 2. This is my perfect square. For 80, well, you might say 8 times 10, but neither 8 nor 10 is on this list, so I'm not going to choose that. Does 4 go into 80? It does. Let me check and see if there's something bigger. Does 9 go into 80? Nope. Does 16 go into 80? Use your calculator and check. Yes, it does. 16 times 5 is the perfect square in this case, right there, the 16. For 320, you'd really have to go far up the list to figure out which one of these is the highest perfect square that goes into 320. Turns out that it's 64, but let's say that you didn't know that at first. Let's say that you said it was 32 times 10. And then neither 32 nor 10 is a perfect square, so then you said, well, I know that 32 is really 16 times 2 times 10. And with that process, you might be able to figure out which one of these on the list it is. But for our purposes for instruction today, I'm just telling you that this is 64 times 5, and 64 is the biggest perfect square. If you have good mental math, you'll recognize that this is 81 times 2, and this is 9 times 10. So let's look at an example that we haven't seen yet. If you want to square root 96, you would not break it apart into 32 times 3. Why not? Because is 32 on this list? Nope. Is 3 on this list? No. I'm only going to use numbers that are on this list. 16 is a number that's on that list. That's my perfect square. 6 is the other factor. Only one of them has to be a perfect square, not both. And then when I square root 16, that's 4. The root 6 is not perfect. 6 is not a perfect square, so that stays under the radical, and that's the exact value. For the square root of 72, I'm going to go through my list. Does 4 go into 72? Yes, it does, but I bet you there's something bigger. Does 9 go into 72? It does. This is 9 times 8. Or if you have good mental math, you might recognize this as 36 times 2. If you square root the 9, you would get 3, but you'd still have the 8 there, and that can be further simplified. That's really 4 times 2. And if you square root the 4, that's going to be a 2 that you multiply by this 3. If you recognize 36 as the biggest perfect square, then you can go straight to knowing that the square root of 72 simplified is 6 root 2. I want you to try these 5 at the bottom, and in the next video we'll see how you did. Times 10, and 9 is the perfect square. So again, looking at this list of my perfect squares, the process for simplifying square roots is I pick a number out of here that multiplies times something else to make this that I'm trying to simplify. We broke 96 apart into 16 times 6, but not 32 times 3. Is 32 on this list? No. Is 3 on that list? No. Neither of these are perfect squares, but 16 is. And 16 can be square rooted to 4 because it's 4 times 4. The root 6 doesn't simplify because it is not perfect. Only numbers that are perfect squares can simplify to a number outside the radical. What is the highest perfect square that is a factor of 72? Oh, I know 9 goes in there. 9 times 8 is 72. So 9 is a perfect square. But there's also a perfect square inside of 8. It's 9 times 4 times 2. These are both perfect squares. You can simplify it that way if you wanted to. You could say, I know there's a perfect square of 9 and 4 and 2 in there. Or you could recognize that 36 times 2